Our last lesson in chapter 4 is 4.8. We're going to be solving equations that contain fractions. We know that's a couple of things that's pretty complicated. But we're going to be doing these using the addition property of equality, the subtraction property of equality, multiplication property of equality, and then we'll have some where you have a couple of different steps. Once we struggle through this beginning, then I'll show you a way to make this much simpler, to take it back to whole numbers. So let's work our way through this. We're going to use the addition property of equality, which says if you add the same thing to both sides of the equation, everything will stay equal. The new equation will be equivalent to the old one. In other words, it'll have the same solution. So when we look at this, x minus 3/10, we know in the end we want this. This is what's standing in our way, so we're going to get rid of that. They've subtracted 3/10, so we're going to add 3/10 to both sides. So these are gone, and we are indeed left with x. Now, when we add over here, we have different denominators, so we need to take care of that. I'm going to use 20 as my denominator. So this one's done for me. This one I have to change. So 10 times 2 is 20. 2 times 3 is 6. So now when I add these together, I get how many 20ths? Like 15. And I can simplify that. I can divide the numerator by 5 and the denominator by 5. And in the end, x is equal to 3/4. Same thing here. We want in the end this. Have a little trouble writing here. And this is what's standing in our way. They've subtracted a third, so we're going to add a third. I don't know why I did that. We're going to add a third to both sides. Here's the equal sign, and we're adding it to the left and to the right. These are gone. They equal 0, and w plus 0 equals, now we're going to have to add these, but they have different denominators. We can use 15, 4/15, and we're going to change a third into 15ths, which means we'll multiply by 5 top and bottom, and we end up with 4/15 plus 5/15 would be 9/15, and that can be simplified. We can divide the numerator by 3 and the denominator by 3, and so w equals 3/5. We did that before, but it was with whole numbers. Now, we're going to use the subtraction property of addition, which says that we can subtract the same thing from both sides, and the resulting equation will be equivalent to the one we started with. So we're looking at this problem right here. And in the end, we want this. This is what's standing in our way. So they've added a half to that. So we're going to subtract a half from both sides. So these are gone, and we're left with x. On this side, we're going to subtract 1/2, or we're going to add a negative 1/2, however you want to see it. I can use 4 as my denominator. And 1/2 is the same as 2/4. We double this and double this. Okay, so how many fourths do we have? -5 minus 2, or -5 plus 2. -5 plus -2, which would be -7/4. And that's our answer. This one, in the end, we want y is equal to, and this is what's standing in our way. So they've added a third. We're going to subtract a third from both sides. So those are 0. And on the left side, we need a common denominator. And I think we can use 9. So we have -7/9 minus, to go from thirds to ninths, we'd multiply by 3, top and bottom. So we have negative 7 minus 3, or negative 7 plus negative 3. Those are the same. If you change the subtraction to addition, then you have to change the sign of the number. So this is going to be negative 10 ninths. You can leave it like that, or you could change it to negative 1 1/9. Either of these would work for me. So that's addition and subtraction property of equality. Now we're going to do the multiplication property. And what this says, you can multiply or divide both sides of the equation by the same number, and the resulting equation will be equivalent to your original one. So we're going to do that. As you can see, 4/5 times x. So we're going to reverse that, and we're going to divide both sides by 4/5. Now, dividing by 4/5 is the same as multiplying by the reciprocal. So even if we say divide by 4/5, we're still going to be multiplying by the reciprocal. And this would be 20 over 20, which is the same as 1. So this is really x. This is 1x. This is equal to 1. And on this side, we're going to multiply, so I'm looking for cancellation. I can divide this numerator and this denominator by 2, and I end up with 5 on the top, 14 on the bottom. Okay, the next one, we've got 3/4 times x. So we divide by 3/4, which is the same as multiplying by 4/3, and we have to do that to both sides. So these are equal to 1, and I'm looking over here for cancellation. I can divide this numerator and this denominator by 2, and I end up with 10 on the top, 9 on the bottom. 10 ninths, or 1 1/9. This one, it's kind of written backwards, but that's okay. Y is that's what we're looking for. Y is multiplied by negative 1/6. So we're going to undo that by dividing by negative 1/6, or multiplying by the reciprocal, which would be negative 6. I really didn't leave room to write it in there, but I'm going to multiply both sides by negative 6, because negative 6 is the reciprocal of negative 1/6. If you multiply these, it'll be positive. You have 6 on the top, 6 on the bottom. That's a whole. So these make 1, so you're left with y, and over here, signs are different. Negative, and 6 times 8 is 48. Okay. Again, we have the same kind of thing over here. This is what we have to get rid of. We have to make that 1. So we're going to divide by negative 1/4. Not really. We're going to multiply by the reciprocal, negative 4, both sides. So these would equal 1, so we have y. Signs are different over here, negative 28. You can always stop the video and go back and rewind it and so forth. Here's a couple more. Okay, and this one, here's x, and that's what we want in the end. And we are going to divide by negative 4. We're going to divide by negative 4, or negative 4 over 1. So these would cancel out. They would equal 1. And over here, we have this problem. Negative 2/9 divided by negative 4 over 1, or negative 2/9 times negative 1/4. So I'm always looking for cancellation. Once I get to multiplication, I can divide this by 2 and this by 2. So signs are alike, so it's going to be positive. And we have 1 times 1 on the top and 9 times 2 on the bottom. Now let's look at this one. We're going to do the same thing. We're going to divide by -4. We're going to divide by -4, or -4 over 1, which is the same as multiplying by the reciprocal. And again, this is going to be positive, and I'm looking, now that I'm in multiplication, I'm looking for cancellation. I can divide 2 and 4 both by 2. So y is equal to, we said this is positive because we have a negative times a negative. 1 times 1 is 1, and 5 times 2 is 10. Here we have some multi-steps, so we have some multiplication and some subtraction in both of these. So, remember we talked a couple weeks ago about wrapping a present and unwrapping a present. The actions are in the opposite order. So even though we do multiplication and division before addition and subtraction, that's when we wrap the present. When we're unwrapping it to find the mystery of it all, we're going to do the addition and subtraction first, and then we'll deal with the multiplication or division. So this is our first thing we got to get out of there. They've subtracted 1/3, so we're going to add 1/3 to both sides. So these are gone now. And we need a common denominator over here. 6 will be perfect. 3 times 2 is 6. 1 times 2 is 2. We're adding these together, so we have 7, 6. So 3/4 x is equal, that's what we have left over here, is equal to that. So we're going to divide both sides by 3/4. Not really. We're going to multiply by 4/3. We're multiplying both sides by 4/3. On this side, this is going to be 1x, and I'm going to do some cancellation over here. I can divide the 4 and the 6 by 2. I think that's it. So we have 7 times 2 on the top, which is 14, 3 times 3 on the bottom, which is 9. So it's either that or 1 and 5/9. Either one of those would be fine. Okay, we've got another one. Again, we're going to deal with this first. They've subtracted. We're going to add 1/4 to both sides. Those equal 0. So we have 2/3 x is equal to whatever this is. We need a common denominator. I think we can use the 4. So this one's done. Times 2 times 2. Okay, so 6/4 plus 1/4 would be 7/4. Now we still got to get rid of this, so we would divide by 2/3 or multiply by the reciprocal, because that makes 1x. And on this side, I'm looking for cancellation, but I don't see any that I can do. So I multiply the numerators, multiply the denominators. If you wanted to change that to a mixed number, it would be 2 and 5/8. So there's a lot to do, a lot to think about when you're working with fractions and equations. So to make things easier, we're going to look at a little process called clearing fractions. That means we're going to get the fractions out of there, so we're only left with whole numbers, and we like those a lot better. So what we're going to do, in order to do that, we're going to multiply all the terms on both sides of the equation by the least common denominator of all the terms in the equation. So these are all things that we know how to do. We know how to find the least common denominator. We know how to multiply fractions, so we're cool. So we've got 3 denominators here. they've kindly given us problems in which we can use the greatest denominator. So we're going to multiply everything by 8, or 8 over 1. Everything. Now what's going to happen is as you cancel in all 3 of these multiplication problems, the denominators are going to end up with 1, which means we've got a whole number. So we can divide this numerator and denominator by 8, and we end up with y. Here we can divide this numerator and denominator by 2, and we have 4 times 3, which is 12. Here we can divide this numerator and denominator by 4, and we end up with 2y. Now, we don't have any fractions, so we can't use that as an excuse. But we carefully pick this so that it's divisible by each of these denominators. And that will get rid of denominators, which gets rid of fractions. Okay, now we're ready. I'm saying let's get the constants on one side, which we have. And now let's get those variables on the same side. Since this is over here, let's get rid of this. So we'll subtract y from both sides. So those are gone. And 2y minus 1y would be y. So there's our answer. Okay, we've got 3 more of these to do. They're really not that hard. What we're really doing, the hardest part is picking out the common denominator. And then after that, it's a matter of canceling out the denominators and solving a whole number problem. So we have 10, 2, and 5. Can we use 10? I think so. So we're going to multiply everything on both sides by 10 over 1. So you can see that we can cancel this numerator and denominator. We can divide both of those by 10. Here we can divide them both by 2. Here we can divide them both by 5. And now we're left with x plus 5 equals 2x. And again, the constants are already on this side, so let's get rid of this one by subtracting x from both sides. So 5 is equal to x. That's our answer. Okay, let's look at this next one. Oh, we've got a whole number here. We know that the denominator will be 1. So we have 7, 1, and 14. I'm thinking we can just use this 14. So we're going to multiply everything times 14 over 1. Now that I'm in multiplication, I can cancel. So I can divide this numerator and denominator by 7. So we have 4 times, this is going to be negative. Negative times a positive. So this is going to be negative 8x minus, 28 is equal to, and I can cancel here, 3. Okay, we're going to get rid of this first. We got to get these over there, so we'll add 28 to both sides. Those are 0. So we're left with negative 8x is equal to 31. And now we'll divide both sides by negative 8. So x is equal to, I don't know, negative 31 over 8 or negative 3 7/8. Either one of those would work. This is the mixed number. This is the improper fraction. Okay, we have one more to do. And again, we have a whole number, so that's going to be over 1. So it's a fraction. Can we use the 8? I think so. So we're going to multiply this by 8 over 1. We're going to multiply this by 8 over 1. We're going to multiply this by 8 over 1. And you can see that the denominators cancel out here. Here the denominator is going to be 1. Here we can divide both by 4. So we have negative 3x minus 24 is equal to 2. So the x's are already on this side, so this is equals. Let's add 24 to both sides. This is 0, so negative 3x is equal to 26. And now we'll divide by negative 3. And we are left with x is equal to negative 26 over 3, or negative 8 2/3. The bottom of the page, all you have is a little review of how to solve equations. Consider clearing the fractions. It seems to me like if you can find a common denominator, then you can just, to multiply that number by everything, all of the denominators cancel out, and you're left with whole numbers. We didn't have any of these that had like terms on each side, both on the same side, so we didn't need to do that, but you would. Collect the variables on one side, collect the constants on the other. That's what we did. Then make the coefficient of the variable term 1, and then simplify if necessary in the end.